We are now recording, and I'm going to share. All right, so I'm sharing the document. So today, if you looked in the calendar, we are going to focus on two things, two problems. We are going of the TCP/IP attacks, right? So we looked at that last week. We were looking at, we started TCP/IP attacks. I basically went over denial of service. We also talked a little bit about SYN cookies, right, and all those principles. So hopefully you're familiar. Also, as usual, I strongly recommend that you read the chapter. So the book is really great, and a lot of information is in the book. And a lot of my notes, and the lectures are coming from the book and the labs, of course. So definitely follow along. I think this is chapter 16 in your book. So last week we talked about denial of service. The other two problems that we have to work through are TCP reset. So I'll talk about that today. I'll start with that one. And that should be a fun actually thing that you can do. And then after that, the TCP session hijacking, which is a much more complex problem, right? So that one will take you a bit of time. It's one of the hardest. I should warn you at this point, it's much harder than all the problems we've done before. It's actually probably one of the hardest, and not really because of understanding it, but because of making it work. Right, so it'll take a lot of trial and error. This one, we're basically going to do it in using the tools of NetWalks and in Python. So we won't be looking at any C code here. And then as time permits today, I might have time to do a few other miscellaneous things. Okay. All right, so let's go ahead and get started. All right, so I have some slides about this, but I'll start just with my notes, kind of thinking through this. So we'll start with TCP reset, and then we'll go from there. So I've started grading your homework assignments, so they're looking good mostly. All right, so just keep it up, looking good. All right, so now let's go ahead and share whiteboard. These notes are coming basically from your book. So these solutions, if you will, they're in your book, so I can share them, of course. And they're not really solutions; they're more just like code, right? More just the logic of how this should work. So today, if last week, so we're currently in TCP/IP. Let me change this. All right, so change colors here. All right, so let me, so we are currently in TCP/IP attacks. Now, remember the disclaimer for this problem. Do not, because you're going to be breaking TCP connections, first of all, well, I should say, okay, so we've covered denial of service, the SYN flooding, we covered that one, SYN flooding. All right, and now today we are going to cover two more interesting ones, which are TCP reset. So we're going to cover this one today. And we're going to cover, or start at least. This one, this takes a lot to grasp sometimes. the TCP Session Hijacking, but it's a very interesting one. Right, so hijacking. All right, so both of these are in your book. Just going back to the reset, remember the disclaimer. In essence, in the lab, you have to break TCP sessions between Telnet, SSH, and also multimedia, such as, I guess, YouTube, Netflix, you know, which are based on that. So you will be able to do the TCP. The Telnet is easy to do, right? Because it's absolutely not encrypted. SSH, you might have a question, well, can I even do it because, you know, is it encrypted or not? Well, as it turns out, SSH is encrypted on the TCP header. So the crypto happens here in the payload, basically, the crypto. So really, and then this is IP, and this is the Ethernet. Right, so really it only happens in the payload, which basically means that it will work, okay? It will work because, you know, let's say the payload is encrypted, but not the parameters that you need to reset, you know, the flags that you need to reset the connection. So this should work. All right, breaking this. And as it turns out, also then the multimedia uses the same approach. YouTube, Netflix, they kind of encrypt, you know, above the TCP layer. So these should also work as well. Okay. Now this would not work if it was some situation where you're sending, let's say, these packets over a VPN or something like that, where, you know, the whole thing. Let's imagine the entire packet was being encrypted within another packet, and, you know, in that case, that would be, you know, wouldn't work because you'd have to break the VPN tunnel, let's say, or the encrypted tunnel before you can actually get in here. But as far as our problems, this should be okay. So remember that in this scenario, because these are all TCP IP attacks, they're always on the assumption of a client-server architecture. Client server. This assumes an established TCP connection, okay? All right, so pretty, you know, this is really important. So the disclaimer is, if you're downloading data from Netflix or YouTube, do not target the Netflix or YouTube servers. Nothing will happen per se, right? Technically, but they could flag you as you sending, if you start sending them a lot of TCP reset packets, the server will flag you, and you know what happens after that. Well, bad things could happen, you know, after that, right? So you never know. They might blacklist you, and or they may even, you know, they could even like investigate. Or so definitely do not do that. Instead, target yourself, right, your client machine when you do this. The book does say that this is fun, like if you know, you live in your dorms and your roommate and whatever, they're watching Netflix, you can break their connection and kind of mess with them. You know, again, that's, you know, it's in the book. So the book is really funny sometimes. So definitely, I strongly recommend that you guys read it. But anyway, these are some of the things that we're doing. As I said, we'll do both of these with 3 tools, NetWalks or NetWag. And I'll try to provide as much information as you need. Python, Scapy, and and Wireshark, of course. All right, so these are your 3 tools that you will need. We're not going to be using C, C++ in this one. We'll use C++ again when we do firewalls. We'll look at a firewall and see again, just kind of get, you know, the same thing, look under the hood, see how that works. that uses the, we'll have to learn a little bit about the Linux kernel module, but you guys are experts in Linux, so that should be okay. So the LKM Linux kernel module, we'll take a look at that then. And then, of course, when we do VPN, we'll look at C again. I mean, they're the only efficient ways of doing those things. And so we'll take a look at that when we do those problems. Keep in mind, now there's one note in these is that sometimes it may happen that Python, as you know, Python is built on top of C++, so it's a little bit slower. Now these attacks, both of these, require speed, okay? And so we actually, in fact, we need sniff and spoof, right? So hopefully you guys saw, you understand now the concept of sniffing, you understand the concept of spoofing, and in the ping 1.1.1.1 or 1.2.3.4 problem, you probably understand, hopefully by now, that that requires sniff and spoof, right? That you need to send out a packet, capture the packet, copy the packet, send it back, right? And that's why you had that mem copy in C, but also in Python, the sniff and spoof code that you have to write. So this one is also similar principle in both of these. You need to be able to do sniff and spoof. So both problems have similarities. It's just that the data of the spoof packet here is a lot more. So this packet, you know, the spoof packets require a lot more information than the reset packet, which doesn't need that much, to be honest. So these are the things that I'll talk about today. I'll get into the code again. Only Python code today, probably. You know, and how to spoof these packets. Again, remember, this is at the end of the day, it's a new family of attacks, right? So the family of attacks that exploit vulnerabilities in the network. Not vulnerabilities, but just the design of the network, okay? So this is network security, of course. And what you're trying to learn right now is, you know, all these, some of these attacks, because there's so many of them, we're just covering some basic types that I mentioned last week, if you remember. But this family of attacks centers around spoofing packets to exploit the vulnerabilities, not the vulnerabilities, the design of the network. Because they're not vulnerable, they just are. That's just the design. And clever people are always trying to find ways of figuring things out. All right, so let's then, since I've kind of laid out this idea, let's start with reset attacks. So the TCP reset attack. Okay. All right, so the best way to think about this is, you know, you're going to have netwalks, you're going to have your Python script, and you're going to have Wireshark, and then you need to, let's try it first with Telnet. So with Telnet, you're going to, again, have a Telnet server and a Telnet client. Okay, you've established already the connection so that if on the terminal here you type ls, you will get the output of this. Another way of checking is if you do ifconfig, right, then you get the IP of this machine. So that's really the goal there. Remember, relevant things when you establish, and I'll talk about this, but when you establish a TCP connection, the key things, and this should be, of course, obvious by now, is that you have IP addresses, right, of the connection. So, you know, as you send a packet in the network, right, the session is established by the port numbers and the IP addresses of the connections. Really, you can think of it as the sockets, the two sockets at the two endpoints. So this socket, right, and then this socket over here, which, you know, a socket, as you know, consists of a combination of an IP and a port number. So usually this is the server, which means this has port 23 open, right? So that's the telnet port, and it's going to be some IP, I don't know, 192.168.1.3. Then here, the port number will be some high number. Let's just say, you know, 48, I don't know, some number. And then this is going to be 192.168.1.11, let's say, right? So those are your two sockets that establish the connection and the session, really. And then after that, usually the only thing that follows is the sequence number, right? The sequence number. All right, so let's go ahead and think about this. So basically, in the simplest, so here's the difference between the reason why you have Telnet, SSH, and multimedia. So in Telnet, basically you type something, right? You have an exchange of packets, and then that's it. The connection is still established, but there's no more transfer of data. No data is being transferred. So it's really like the connection is just waiting there. So if you go to Wireshark on your computer, right, you can look up, okay, Telnet, just type in, you know, the Telnet application, look it up, and now you can see just the packets that have been exchanged for Telnet. And then you can look at the last packet that was sent. You have there all the parameters that you need, IPs, ports, and the sequence number. And these are the things that you need to establish a communication, right? So to authenticate, so you can then send, you know, a reset packet. So this should apply for Telnet. This should apply for SSH. Now in multimedia, because both of the SSH will be the same, you log in, type a few commands, stop typing, the connection kind of stops there, right? After any data was transferred back to you, you're really just, you know, you're good to go. However, in the multimedia problem, you have a slight problem. And the slight problem might have to do with the fact that here, what's happening? If somebody is watching YouTube or they're watching Netflix, data is being sent, right? So there's going to be a lot of data being, you know, you're receiving data from the web server, or you're looking for a video or a movie on your YouTube, but it's all being, there's a lot of data exchange. Now today we're going to see that, and you, I'm sure you know this already, the data exchanged affects sequence numbers. Right, so that's one of the things that we'll discuss. And because of that, because it affects the sequence numbers, you know, if you don't have the sequence number, obviously, you know, the right sequence number, you may not be able to fool the computer into thinking that, you know, that your spoof packet belongs to that session. Okay, that's the tricky part with this one. And so that's why this one becomes a good candidate for something like sniff and spoof, where you automate that process. Because if you know, we're slow, and if you go and go on Wireshark to look at everything, you know, it'll take you a while. By the time you find a number, a lot of packets may have been exchanged, okay? So for this one, that's where, whereas these two, the Python might be, and all three actually, we'll use Python and networks. I think that will probably be the best approach, okay? Any questions so far?
No questions.
Questions. All right, good. So, all right, so that's the idea, right? So we need to figure this out. So in a telnet connection, you know, we have our IPs from our client and our server, and our goal as the hacker is to break up this connection using the TCP reset attack, which it's really just a flag, you know. So you might, you know, I don't know if you guys, you know, get that part, but it's really nothing more than setting a packet with the right parameters and then setting a reset flag to true. So before launching the attack, we need to figure out some essential parameters, though, needed for constructing a spoof TCP reset packet. And as I said, you can run that with, you know, Wireshark on the attacker machine, and looking for the most recent TCP. So that's why certainly start with Telnet as your first reset problem before you try to tackle the other ones. Now they're not so difficult. I just, you know, but I wanna explain some of the issues. All right, so again, you'll look for them. Usually, log in, let the exchange happen, authenticate, then type a command like ls. At that point, let it settle in Wireshark. Let it settle in Wireshark, and then look up the, you know, look up the last telnet packet, right? That's usually where you're going to need to be, is look at the last telnet packet. You always have to think also in the direction that you're going, okay? So think about that. Are you going in that direction or are you going in that direction? Because you know, packets in both directions have sequence and ACK numbers, but they switch them around. So knowing the direction that you're going in, because you're spoofing that packet, right, from A to B or B to A, so you really have to think in terms of that. All right, so obviously in Wireshark, you can get the parameters that you need, which are usually the ACK number, the sequence number, source IP, destination IP, source port, destination port. Keep in mind, as I said, Wireshark sometimes shows what are called the relative value. And the relative value would be that you'll see sequence numbers like 1, 5, you know, 7. If you see that, that's a bad sign, okay? These are relative numbers, because an actual sequence number would be something like, you know, something like that, right? And then from here, you start adding whatever, you know, the data size might be, right? To increment the, but Wireshark sometimes doesn't show the absolute value, it shows the relative value. But obviously, if you're trying to spoof packets, typing this in as the sequence number or this is not right, right? It has to be this. So this is what is actually in the packet. It's just that Wireshark will show that. So there is, in your book, you can see in your book kind of how to fix that. Okay, so I just recommend that. All right, so let's see. The question here is, I thought you said that we need to sniff and spoof for resetting with Python. Could we just write the code to sniff the packet and spoof it to kill the telnet connection? Okay, so I just said in here, right, that with telnet and SSH, you can really just look at Wireshark, because I explained you type something on the terminal, ls, you exchange some data, and then there's no more packet exchange. Does that make sense? There's no more packet exchange. The problem is if you have a protocol that is constantly changing data back and forth, then if it's doing that really fast, even when you go to Wireshark, by the time you've looked up a number, other numbers have appeared. So you really have to wait for it to stop, okay? And so with Telnet, it's pretty easy because Telnet is not very active, right? So Telnet is just, you type, you get a command. You remember what Telnet does, right? It allows you to connect to another computer so that you can type commands on that other computer. So we'll see right now some examples of doing this with NetWalks and with Python. Does that answer your question? Okay. All right. So let's take a look at it then. All right. As I said, we will look at it with both tools, NetWalks and Python. All right. So we can assume, for instance, that we saw in Wireshark that the port number, of course, is 23 for Telnet, and then the other port is 45,634. So we've got that data, right? We've got that data. These are the port numbers. Okay. And that you know, whether their source or destination just depends on the direction of the packet that you're looking at. Okay. So we're only looking at Telnet right now. All right. Now we may, you know, we can look up the sequence number, of course, sequence number. Okay. Also from Wireshark because it's not moving, right? So it's the packets are not being exchanged anymore. So we just look at the last. So look at the last packet in that connection. In the Telnet connection. Okay, so I already explained that you get it from Wireshark. It's a big number. I already explained that, showed an example of that. I already told you that in the book, you can find in the book on section 16.3.4, basically how to change from absolute to from relative to absolute sequence numbers. Now, with this information collected, the IPs also, then you can proceed to generate the spoof reset packet, right? So now this information, and that's usually all you need, right? So now you can generate the reset spoof packet, okay? Now, the first way I'm going to talk about this is basically just to look at writing our own program using Python. However, I will also show you how easy it can be to do this with NetWalks or NetWag. And there's a couple of numbers that you can use for that. There's 40, and then there's the other one I can't remember right now. I think it's 78, I want to say. But we'll look at that. All right, so let's think now of the script then for a reset packet, right? So it would be something like import scapiol, scapi.all, import, or rather that should say from, sorry. From scapiol, import all basically. All right. And then again, you know, what do we need? We need to send a reset packet so that, again, hopefully this is starting to make sense. You create IP layer, right? And that's going to be uppercase IP. This creates the header. So we're building a packet, spoof packet. It's going to have Ethernet, IP, right? TCP, right? Some kind of a payload. So if we don't specify those headers or those fields, then remember that's just going to be filled in by default. And that's the great thing about this that I like, right? It's that, you know, we don't have to worry about what they are, and we just set up the basic one. So what do you need to set here? Source, right? And this is just going to be the IP, so 10.0.2.69. comma, and then destination, right? And these are the IP addresses. So 10.0.2.68. Okay, so we've specified the IPs now. Then the next thing is to define the TCP layer. Notice that this is not a sniff and spoof, because, you know, we may not need it. The sniff is coming from Wireshark, so this is just the spoof part. So then we do TCP layer over here. So TCP layer, it's going to take the TCP header, okay? And that's going to be the source port. Remember, this depends on the direction of your packet, right? Which way you're sending it. Think the recommendation is usually to break it. In the telnet, it doesn't matter. It can be telnet or server, or client and server. But in the multimedia, remember to only target the client. So source port, let's say, is 23, right? Your telnet port. Then destination port is that number I had, 45,634, some high port, right? Because you usually get high ports on the other end. And then the flag. So this is an important thing here. Notice flag. And the flag in this case is the R flag, which stands for reset. Now, additionally, the sequence number that you got from the last packet, and that's really all that you will need to make this one work. So this would come from Wireshark, okay? That would come from Wireshark for telnet, for the telnet part. Then you create the packet here. And of course, you just do IP layer. And then we use a / to kind of concatenate the pieces. So, you know, now we're concatenating these two. So then this one would be TCP layer. And that's it. You have now spoofed a packet, right? That's pretty much constructed now. And then you can just go ahead and you can view the data of it. So if you want to view its data, you can view it, how you constructed it. It looks a little bit like Wireshark. And then you send it out. And verbose, you can see some information, and that's it. That is, this is going to be for spoofing a reset, a TCP reset for the telnet problem. Make sense, guys? All right, so it sounds like you guys understand. If you're successful with this attack, what else? All right, so if this is making, if you get this to work, the output of this one. So what I will be looking for in your lab report, if you're successful, is it'll say something like this: connection closed by foreign host. So please highlight clearly so I can see this. Connection closed by foreign host. Right? That's the output that should come out when you break the telnet session. All right, so I'm being asked here, the source IP is the attacker. So the source IP is the attacker. Think about the question you just asked me. That's actually a good exam type question. I could give you a problem and I could say, name this IP, and then you guys, say something like the source IP is the attacker. So the idea is, remember that you're spoofing a packet, right? So remember the definition of that. If you're an attacker and you're sending packets to create bad things, and you know that these things are going to be logged, do you actually want your IP as the attacker to be recorded? You don't, right?
No.
Exactly, you don't. So in a spoof packet, actually, they're all either the so let me see, there's another, okay. So the student, yeah, so got it. So basically, it's actually the packets of the connection here, right? Remember, that's what I said a few minutes ago when I talked about this. Remember, I talked about the sockets. So the session between a TCP, situation here is that, so then, you're trying to inject packets in here and pretending you're basically C or Zelda, right? You're the attacker, but you're trying to inject packets, and the packets are mimicking the connection between A and B. So that's what you need, that information. So you need the socket information of A and B, and never really anything to do with the C packet. None of your IP source. If you do that for real, if you do that to Netflix and they forward you to the FBI or something, they'll find you, right? They'll find your IP. You don't want that. All right, so let's continue then. Okay, so that's the code right there, and that should work. And as I said, if you're successful, this is what I need to see actually in your lab report, right, for the telnet session. Now, there's a few problems with this. One problem is, as I said, SCAPI can be slow, right? And that's the reason why, just in case, I will give you also the NetWalks solution. NetWalks is a tool. It's built on top of C. It's a lot more faster. And so, but I think this one will work. At least for telnet, it should work. It might not work though for the multimedia one. Because the point is that with the multimedia one, if you think about it, if the multimedia exchange has stopped, it means basically that you already saw the movie, right? You already buffered down all the movie. But if it's still going on, it means you're in the process of watching the movie. Well, the whole point of it is, like, the scenario of you disrupting your friend's movie is that they don't get to see the end of the movie. So then that means that there has to be an exchange going. By definition, that means sequence numbers are being changed. And we'll see that in a while. We'll see that a little scenario or example of that whole TCP idea. All right, so it seems like this is clear. All right, so I don't see any other questions or hear any questions. All right. So SSH is pretty similar, okay? SSH is very similar. There's nothing really going on. The only difference is, of course, Now it's going to be SSH on the server side. So you have to start the SSH server. On this side, it's going to be what? It's going to be the client SSH. Again, the session is defined by the IP sequence numbers. The SSH server will be a different port number now, 22, right? And then every time you break the connect, oh, another thing, another common mistake I always see with students is that every time you break the connection, you might have a different port number here, okay? So be aware of that. You'll have to change that port number. The IPs usually don't change. Obviously, this won't change, but this port number will change. Okay, so just be aware of that. All right, so this is for SSH. There's nothing really I need to say. You just literally, the script would work, I think, if you just change this port number to 22. You change that to 22. And of course, making sure that you've addressed these values, right? So every different connection, if you remember last week, we were talking about how sequence numbers actually are randomly generated as really large 32-bit numbers. And so basically, you know, every connection, they will change. That's part of the protocol. I already talked how SSH performs the encryption at the transport layer, which is above your network layer. And so only the data, basically, of the TCP packets is encrypted, not the header itself. So that makes TCP reset should still be successful here. Okay, so somebody has a comment. Okay, so somebody is asking me, how do you start SSH server? So in ITS 372, you guys, if you remember your services lab, you guys remember that you learn how to do sudo service SSH start, right? Or you can always do sudo apt-get install SSH, and that makes sure it installs it and it starts it. But so sudo, so if I write that on here, sudo service SSH start, okay? And that should start the SSH service, okay? All right, so I think that answers, okay, that student's question. All right, so we've talked about SSH. So now comes the more complex problem of TCP reset on video streaming. This is probably the most fun because you can actually try to disrupt things, but it's a little bit more complex. So let's think about this one. So this is more like, you know, you're having fun with, you know, the scenario, the academic scenario is that you're, you know, playing a prank on your friend, your roommates in your dorms, and siblings, you know, etc. They're watching videos from the internet. Most of the video streaming sites, such as YouTube, Netflix, use TCP. Okay, so that's a good thing to know. So you send a TCP reset packet to your roommates' machines and break their TCP connections, right? So obviously, same things. You need to know your friend's IP. You need to be able to ping them, obviously, first. So you're going to be in the network. And then you need to know their port numbers, right? And that's about it, that you need to know the IP and port number of the server as well. And then the scenario is you send a TCP reset packet to your roommate's machine and break their TCP connections with the video hosting. So hopefully interrupting what they were doing. So here, in theory, this is very similar to the telnet one. So now I should say, so TCP. Similar TCP reset. Let's call it multimedia. So this should be very similar to the attack on the telnet, but there's the unique challenge of resetting video connections. And the challenge is the sequence numbers. In our attack against a telnet connection, we just sniff the packet, basically with Wireshark, get the sequence number, and then type it, and then type in our command. We do this manually. And the key thing is you can do it manually because remember, as long as you don't type anything on the telnet connection, no packets are going to be exchanged. The telnet connection is just waiting there. So when you have your Wireshark on, the number of packets that it's picking up related to that telnet connection just stops, right? And you can find the last one. So you have the last one, therefore you have the sequence number. Here, it might be a little bit more challenging. So in video streaming connections, we have no way to stop the packets between the client and the server. So the sequence number are going to increase very fast before, and thus making manual collection more difficult. Therefore, for this one, we need a sniff and spoof, similar to the 1.1.1.1 problem that we've looked at. So as you can see, we're kind of repeating the same principles. And that's the great thing about these problems is once you get a basic idea, maybe in the beginning it was hard, but once you get the basic idea, you realize, oh, I just have to understand the protocol. I just have to modify some of the fields. I got it. It's really like that. So then the trick is we have to automate this attack, okay? So instead of using manual sniff and type, as you've done, that's why you have so many problems related to sniff and spoof, right? You have the 1.1.1, you have the trace route. All of these are meant, it's really the same code, and they're meant to kind of get you to understand this idea that you can't always get things manually. So we need to create a program that sniffs the video streaming packets, gets the sequence numbers, and other essential parameters, okay? And then automatically sends out TCP reset packets. Remember also that this assumes something that's very important in a physical environment. You have A and B, and there's a cable, right? But there's something called a network tap. So the network tap is a thing that mirrors certain ports, right? So the idea is that the connection between those 2 points is also mirrored here. So you can connect a computer to that mirrored port, and anything that goes through here, you see here. And once you see it, you sniff it, and then you spoof it, right? And you send it back out into the connection, and then it's basically going to get to the right destination. This is usually, this device, this little tap is usually a switch, but it's a special kind of switch. I mean, it's a switch with 2 ports that are mirrored. But just be aware of that. That's kind of a technicality physically. But in our VMware, we can basically make this happen. Okay. Any questions about that? Okay, doesn't sound like there's any questions. All right, so let's keep going then. All right, so the question then is, we need to write the script to break, let's say, YouTube or something, right? So we're going to break a YouTube connection. Let's go ahead and create the script. This is, again, sniff and spoof. Right, so by now this should be clear in your minds, right? So you do from scapiol, or scapi.all, sorry, import all. Right, same thing as before, nothing has changed there. Then we need to have the basic layout. For sniff, so this is sniff, and then spoof. Okay, so sniff is what? We grab packet equal sniff, okay? And then we do the filter expression. Remember, this is the first thing you did in the semester, so you should know how to do that. I'll leave that to you to figure out. But obviously, TCP packets, where an IP is a certain one, source or destination. Remember, whenever you're thinking of sniffing, you should think in terms of, I'm here, like you're there, and you're looking at every packet that's going. So you need to, so the direction is very important, right? So which way is it going? You have to think about that in those terms. So once we have the filter, then we can go ahead and say, well, whenever I capture that type of packet, I'm going to send it to spoof TCP. What is spoof TCP? It is the function that I have assigned, that whenever I'm listening to something and I capture packets, I send them to spoof TCP. This is the sniffing part. The spoofing part is then here, right? In that you define what spoof TCP is. So, you know, spoof underscore TCP. You're going to then send it a packet, PKT, as like that, right? So every packet that you get from here gets sent there, okay? And so therefore you grab each packet and now you can copy parameters from that packet to create a new packet and then send out that packet. So that's what we want to do here is we're gonna create a new packet called spoof packet. So again, you know, very similar to what we did last week. You know, this is the IP layer, right? Create a variable IP layer, and it takes IP header. It takes IP header. And again, we need to specify then some parameters you probably know and you can hard code if you don't want to copy them, like the destination, right? Let's say it's going to your client. This is the multimedia one, so it should only be the client. So I will write here client IP, okay? Then what else? Now the source, if you want to copy the source, how do you copy it? Who can tell me? How do you copy the source IP? Where is it? It's in packet, right? So it's going to be in PKT. And then out of PKT, I need to look at the IP header. So it's like I just grabbed the packet. Remember a packet, Ethernet, IP, TCP, so on, payload. This is PKT. By saying PKT IP, I'm going to grab this part. Okay, I grab that part, and then from that part, by doing a dot, I can grab the field. So in this case, it's going to be the destination, right? Or the source, depending on what packet you just grabbed, because remember, it's flipping, right? So if the packet that you grab was going like this, now you're going to maybe send it in that direction, right? So I leave that to you to figure out what the appropriate thing should be. All right, what else do we need in this one? probably just that. Everything else is default values. The next step is to define the TCP header, this one, of the spoof packet. So TCP layer, let's call it. And this is going to be a TCP. Now remember, in the TCP, we specify the parameters related to the flags, sequence numbers, destination port, source port, right? Those are the things that you need to set up. So flags, we just set the flags is R, right? Because this is a reset packet. If it was a SYN packet, it would probably be an S. If it was an ACK packet, it would probably be an A. If it was a push packet, it would probably be a P. Okay, so keep that in mind. Those are the fields that are in the headers that you need. Comma, sequence number. Notice that here you're not going to take the sequence number from Wireshark anymore because that would probably be too slow. Instead, you would try to get it from the packet itself. PKT TCP, right? Because again, you're looking at the packet, but now this time around, you're looking at the TCP header. Okay? And then now, we say dot here. And guess what? In the packet, there are two fields, sequence and acknowledgement. And it turns out that it's going to have to be we'll see this in an example, but let's say you have two endpoints and they're both sending data. So they're both sending data. Each one has their own sequence number. So that's their own sequence number. And this is their own sequence number. Random numbers that they pick, and they're being different sequence numbers that increase every time they send data by that amount. But in the packet itself, there's always also an ACK. There's an ACK associated, and the ACK usually includes the sequence number of the other. So for instance, right, so this ACK will be that sequence number, and this ACK relates to that sequence number. You see that? So as you're flipping the packets, you would grab, so if you want this sequence number, then intuitively, oops, you would get the ACK number of the packet. You guys see that? Okay, so everyone's pretty quiet. But anyway, just ask questions if you have them, but that's really the idea. And this concept here, what I just wrote, also applies to the TCP session hijacking, okay? It also applies there. And that's one of the little tricks that we have to kind of be aware of. That's why after this, I usually do another example of just that, looking at the numbers. So we'll take a look at that. Okay. What else do we need? The next thing we probably need in the TCP field is the destination port. The destination port, and this one would be packet. And again, coming from TCP, right? Because TCP will have the port numbers. Okay. So now we need, if it's destination port, because the packets are flipped, this is going to be as port. Right? From the sniff packet, we have to flip them. And finally, then, if we want the source port of the new packet, we're going to do PKT TCP dot destination port, and that's it. And at this point, we close the parentheses, and that's, you know, of this open parentheses here. So these are the fields. So you can see even with Python, you have some fields to fill in, right? Netwalks will have fields to be filled in. C++, obviously, the more faster, powerful. But anyway, that's it. After this, and I'm running out of room here, you can create the spoof packet. So you can just say spoof packet, and it's going to be equal to IP layer / TCP layer. Remember that that's just you concatenating the headers. So basically you take this one and then you concatenate it to that one, right? And so now you have a full packet and all that's left is to send it out. Not spoof. Spoof PKT. And then the verbose. So you can see some output, 0, and that's it. Make sense? This, once again, is a sniff and spoof for the multimedia TCP reset problem. All right, so let's see what else. All right, so now let's actually take a look at netwalks. Okay, so this, remember, this is the Python version. With the, let's say YouTube, right? YouTube's, I don't know which one is faster, whether Netflix or YouTube is faster. That's actually a good question. You can try both, or maybe even some other multimedia service. But now the trick is, an even faster way might be to try netwalks. So let's try netwalks here. So netwalks, you've heard me talk about it all, semester so far. So netwalks is a command line, right? So you have the terminal there. You type up the netwalks command. The TCP reset, I was right, is actually 78. So basically here, we do the same, but just in one line of code, right? So, so you can try this. So to create TCP packets, basically with netwalks, we can do the following. We can take so the TCP reset will be netwalks 78, and then you may need to specify the device. So this is an optional parameter device. So usually in a lot of your computers, I think it is now, it's ENS33 in the VMs. It used to be ETH0, but I think now something like that. Okay. The filter expression, of course, -F filter. And that's similar to the filter expression that you had in the Tcpip code. So similar to filter expression in Tcpip code or Python code. And then you can specify, now remember, it's just going to capture that packet, copy some of the fields, so hopefully it'll copy a lot of things. So you don't really have to define much, right? A lot of these parameters that you see here would just be copied automatically. And so then that leaves you with the opportunity to set some things like like an IP, I think. So -I, IPs, etc. Okay, but that's the general approach to that one. So for instance, let's take a look at this one. Let's say you have a packet that comes from 10.0 to 68, right? And it's some kind of a multimedia or something. So then your command to spoof it back, so the spoof one, and I'm going to write this in blue to indicate that this is for that packet, would be sudo netwalks 78, and then the filter, which in this case would be if source host 10.0.268. That's it, right? So the filter express, because if you think about it, you already told it that you want a reset packet, and you already told it only do that when you grab a packet that has a source host of 10.0.2.8. Well, this red packet is from 10.0.268. So then this command sniffs, captures the packet, generates the blue packet, which is the spoof packet, and it should just copy all the fields like the source port, destination port, the flag it already knows, sequence number, and the IP addresses also, it will have them. And so you have everything. So you can see how the netwalks tool, it's, is a lot simpler to set up, obviously. All right, that concludes our discussion of TCP reset. So as you have seen in our discussion, we went over these three, right? So TCP reset on telnet, so hopefully that makes sense. TCP on SSH, right? And then finally TCP reset on multimedia. Okay. Are there any questions?
No questions.
No questions. All right, good, good. So that sounds good. All right, great. Looks like it's making sense. That's good. All right, so now the next problem, the last one, and this is, it's very important that you do TCP reset first. Go through all the motions. I almost sometimes think that TCP reset is like a warm-up for the next one, right? So for the TCP session hijacking. So this one takes a little bit more to understand. So first thing I will go is, this will take a while to discuss, but you should be able to do it. When did I say the spoofing labs were due? Are they due this Thursday?
Yeah.
Okay. So I'll extend that one more week. So they'll be due a week from Thursday, because I'm only now sort of getting to TCP session hijacking. So that'll give you plenty of time to solve it. Next week, though, if I finish this lecture today, so in the what was I saying? If I finish this lecture today, I should be able to start the next topic next week, which I think is intrusion detection, or we'll see. But so this is, so what I want to say at this point is that of the TCP IP attacks, this is the last problem that we're going to look at. All right, so this is called TCP Session Hijacking. All right, so attack, I guess. So this this one, if we are only going to need to do this with Telnet, okay? So we only need to do this one with Telnet, and I think it's really because it's a challenging problem. So let's think first of all of the scenario so that we are all very clear on what it is that you need to do. Okay, so the scenario is the following. And I think I already have some slides also with this diagram. So if you like, you know, something like that, you can take a look at that one. But it's pretty much the same thing. So you have A and B, and you have C, the attacker, right? So this is the attacker. This, let's say this is client, and let's say this is server. Okay, so client and server there. And yeah. So we have, this is Telnet. So port 23 again. And let's say this is 46.5.24. So we have an established connection between A and B. A, you know, A can open a terminal here. If they type ifconfig, right, they'll get the IP address of this one. So let's say it's 10.0.1.3, and this is 10.0.1.17. So if they type ifconfig on A, they'll get 10.0.1.3. They type ls, they'll get, you know, the directory listing of this machine. So basically, what's happening here is that you send a packet from here, you send a packet from there with the commands. So it's like you send, let's say, ls, right? And then maybe like the new line character, etc. That ls is for the ls command. And then those arrive at B, the server. The server evaluates them, gives you the directory listing, and then it's going to send back the data to you. So the result of ls, I don't know that. I'm just right here, the directory listing. Do you see that, guys? That's basically what's going to happen here. That's basically what's going to happen here with this problem. Okay. So your question might be, okay, I get that, but how does the attacker then get into this? Well, for this one, again, you might imagine you could do sniff and spoof. You know, a full code, a full code like the previous one, or you can manually sniff and then spoof. I would probably recommend that for this one, you do it manually just because it's, although it's more challenging, it might be easier just to do it automatically, obviously, but manually gives you a lot of insight. Okay, it gives you a lot of insight. So you could do the sniff part with Wireshark, and then just the spoof part. And you can do the spoof part with, you know, NetWalks or Python. So what you need to do, though, as an attacker is that you need to know what these packets look like. Not these, not those, but these, right? So these green ones are the ones that you want to know what they look like. Why? Because you want to insert one of these green ones in here. And that packet needs to be the next packet that B was expecting from A. That's the best definition that I can give you. Okay? So think of, you know, you have your telnet session open, right? And you've already typed ls or ifconfig. Send those commands to the server. The server already replied with the IP, and at this point, everything is stopped, right? you know, the terminals are not doing anything on either machine. Your Wireshark, and imagine this is Wireshark, and there are no packets coming in. It just, you know, stopped there, and there's just blank. And so what you need to do is you need to go to Wireshark, grab the last packet that is in that direction, right? So that you can figure out what would be the next packet that you need to create here. And really the easy things are the IP and the port numbers. But the hard part is, again, you have to get that sequence number, okay? That sequence number is critical for you to, and also the sequence and the ACK need to be inverted. So it's very, so I've already, our discussion here of this, you know, where we talked about this, for instance, is relevant now again in the new problem. It is relevant again here in this problem, okay? All right, so that's basically the scenario. Now, what are you going to try to achieve? So if it's a TCP session hijacking, right, and you have a telnet connection, what do you guys think? What would be the goal of doing that? In the previous one, we know we just wanted to break the session, but here we're not trying to break the session anymore. We're going to try to do something else. So what do you guys think you would do?
Send the malicious code to the server.
Enter malicious code to the server. What do you mean by that? Enter malicious code to the server.
When just like this picture, the client sends some package to the server, and attacker just to block the package and send the package from the attacker to server to instead of the client.
So what would you insert then?
I have no idea.
Huh. Right, but you're inserting something, right? And that can be a lot of things, right? Oh, so some people wrote on the chat. Let's see. So one of the things that I want you guys to figure out is which sequence number to do. Usually a Wireshark will tell you, somebody's asking some question on here. So the next sequence number is something to look at for sure, because what Wireshark is doing there is it's helping you to figure out what the next sequence number is that's being expected, okay? So, but going back to what I was saying, the question that I asked was, what would you insert? Well, you already know that here you guys can insert commands like ls, right? So in the past, what I've asked for this problem is for students to insert pwd. What is pwd in Linux? Right, it prints the working directory, exactly. So it just prints out, you know, on the server where the terminal is, on what directory. So usually for this lab, and again, this is important, that's one of the outputs that I would, you know, that's good to have, right? So if you have a screenshot that you did your attack, and then on the client side, you would need to get the result of pwd. You guys see that? So you insert pwd on the server here by the attacker, and then remember that the server does not reply back to you, right? The server will never reply back to you because it doesn't even know you. And it doesn't have a secure session with you. So the server will only reply back to A. So even though so think about what just happened, and this is important because this is why session hijacking is called that. You did not, you as the client, you never typed PWD, like never, right? So you never did this. The attacker, on the other hand, spoofed the packets and inserted PWD into the server. And then the server replies with the result of PWD. So let's say PWD result, which is that working directory, but it doesn't send it to the attacker. It sends it back to the client. So the client will get PWD's results even though it never asked for it. Make sense? So the output that I'm looking for is then that PWD output, okay? That's what I'm looking for, the PWD output. So you might ask the question, but so what's the point of that? If you're an attacker, you're not stealing any information, right? So really confidentiality is, by doing this particular scenario, confidentiality is really not being disturbed, right? Which is true. However, you could do other things, right? You could, it could be a command. Obviously, the commands depend on the user account. So that's an important one. But you might ask, okay, this is not that damaging, right? Not that damaging, because at the end of the day, yeah, you typed the command, but you never saw it. Only A saw it. And so, okay, so that's fine. A saw it. C was never able to disrupt anything. So the question is then, what would be something more interesting to do than, say, inserting PWD? So what do you guys think? What would be better than PWD? Because you can insert this, right? So think about what happened here. You have a computer with a command line, and you're able, apparently, it seems, at least what I'm telling you, is that you can insert in that terminal whatever you want. You see that? Because I'm telling you already, first thing you should probably do is insert PWD. But really, and you should show that. But really, you say to me that, well, that's not so exciting. But then I'm telling you, well, just like you inserted PWD, you can insert other things in there. And the other thing that you can insert is actually anything that you could type on the command line. So one thing that might be useful to insert in here is something called a reverse shell. And you probably saw this when you did like Metasploit things, right? But here you're just seeing how, without having to use some program, you can easily then, in this scenario in Telnet, you can insert a reverse shell. So a reverse shell would give you basically a connection, right, to the computer, so that now you have a new terminal and you can type anything but more freely without having to, you no longer have to inject spoof packets anymore. Basically, you'll insert something on here, right? You'll insert something on the terminal. The terminal will initiate then a reverse. It's like it opens a port and it'll initiate a tunnel to your machine. And at that point, you have an opportunity to do whatever you want with the machine. Does that make sense, guys? Questions?
No questions.
Questions. All right. So it sounds like you guys are getting it. So that's good. All right. So so I spent all this time just talking about that. So really, your homework for this one then is to do these two, reverse shell and PWD, right? So these are the two, it's basically the same mechanism, like the same steps, if you will. You just one time insert PWD as your payload, pretty easy. Second time around, you want to insert a reverse shell, all right? And so we'll go over that as well, those details. So we're not going to finish that today, but at least this gets you. Now you could probably do the TCP reset problems and start looking at TCP session hijacking. All right, so, you know, usually you have to wait. So when you do the TCP session attack, right, you're going to have to first do the three-way handshake. Make sure you've established the communication, as I said, with Telnet. Type some commands just to see the packets back and forth. That's another recommendation I always make. Like type ls, see what happens, look at it in Wireshark. Type pwd, see what happens, look at it in Wireshark, and so on, okay? All right. So I've talked about the session, how that works. All right, so as you're exchanging packets, you know, because of the sequence number, you have a buffer, right? And the sequence number is just, you know, I receive a piece and it's got that number, and I receive another piece and it's got that number. But it could happen that the packet that was supposed to deliver this piece hasn't arrived yet. So in that case, that's kind of blank there, right? So what's going to happen is the computer is waiting for you to complete this with all the sequence numbers. And that's why it's very important to have the correct sequence numbers, because if then you get something that goes like that, you have a problem, right, in the sequence numbers there. Okay, so hopefully that makes sense. That's in your book there, how this works. And there's a little graph actually that's pretty good. So we'll talk about this next time, not today. But there's a graph in section 16.4 of your book, and I strongly recommend that you take a look at that. It talks about the receiver's TCP buffer and the sequence numbers. And so these are sequence numbers. So this might be like X, oops. So this might be X, right? And then given, oh, sorry, so you have X here, and then you receive some data here. And this would be, if this is X, and this is a, you know, this is, let's say, size, I don't know, M. So then this would be X plus M, right? That's how the sequence, these are sequence numbers. So the sequence numbers are related to the size of the data, okay? And then that's how it figures out how to calculate things. So when you, if you want to insert a packet, right, you want, as the attacker, you want the packet to kind of be there. So you need to know what this sequence number is plus the size of the data, M. And that's why guessing that is really difficult sometimes. Okay, and so if you get the number wrong, let's say that you get the number wrong, what could happen is you end up putting your data here, right? And that's going to be whatever, it's an X plus M plus whatever this is, you know, D, that unknown. But the buffer, the computer is waiting for this piece to arrive that goes here, And if that doesn't arrive, it's not going to take your data seriously and it's going to discard it, right? Because it needs to concatenate all the elements in the sequence. So that's really what makes this a little bit complicated with this problem with the sequence numbers, okay? Figuring out the sequence number. That's why you can't just guess them. However, if you go on Wireshark and you look at Wireshark, then you'll be able to see, oh, okay, the sequence number was this, the amount of data was that. Wireshark is nice enough to tell me what the next one is. And now I tell it the sequence number for my packet is X. So in your spoof packet, PKT, the sequence number that you're going to put in is going to be X plus M. And then it's going to know, you know, it just puts it there and it completes it perfectly so that it will accept it as part of that session. But if that's not met, it's not going to like it. Okay? Okay, guys? So there's a graph for that in figure 16.7. Definitely take a look at it. I think that's pretty good. So I think this is a good stopping point because now what I have to do is really get into some other specifics of the session hijacking, but that's going to take a while. So we'll do that next class. For now, you know, let's pause the content here. If you have any questions about the assignment, I'll stay and just answer your questions.